So in this video, we'll quickly look at the Spearman correlation. This is typically useful when you have categorical variables, typically where each value carries a certain rank. For example, we have this x and y coordinates here. You can say that these could be coordinates, or these could be independent variables. X has values which range from, let's say, a1 to a3. And y could have values which range from, let's say, b1 to b9. And I would like to find out whether there is a correlation between the two variables. For example, if x increases, whether y increases, or whether x decreases, and correspondingly whether y decreases or not, or vice versa. So if you have to find that out, it's very difficult if each of the independent variables have categorical values, because I would like to understand, what is the significance of each value, whether a1 is greater than a2, or whether a2 is greater than a1, and similarly whether b5 is greater than b9, or vice versa. And hence I would like to transform this problem into a linear scale, which I would do that by introducing a linear scale, which I would define in a function, in a custom function. And once I have the rank variables, then I would understand how they differ corresponding to their respective central tendencies. So that's how the Spearman correlation computation is based on. It's about converting individual categorical value variations into relatively linear scale rank-based variations, which is on a linear scale, and then we calculate or quantify the total correlation value, which ranges from 0 to 1, or in case of 0 to 1 in case of positive correlation, and -1 to 0 in case of negative correlation. So that's how the Spearman correlation computation is, and we can quickly compute that by, so let me just quickly open the file. So I have this Spearman correlation file, which we will start with one CSV file, and then we'll quickly compute a custom rank function. And this could be anything. This could be up to your choice. So you could make it based on the levels or factors, or you could just quickly use an if nested if else loop to define a specific variation. And similarly, allow to define a custom rank function for y as well. So I will define that. And once I do that, I will have to also write custom functions to apply these custom ranks to the input data variables. And once I do that, I will quickly invoke these two functions, compute the individual ranks. And so my initial categorical values are now transformed into a relatively linear rank scale. And I would use this to compute their variations from their respective central tendencies. So a quick way to do that is define the Spearman similarity function, and then you could make it flexible. So if you'd like to understand the similarity, you could just have a flag variable, and then based on the value of that flag variable, you could define the quantized value, whichever value that is returning as for the computation of this function. You could call it either similarity or dissimilarity, and that could be done based on the integration of whether it's positive or negative. And then I have to again plug back that value, and I can get this. So in this case, I've put the flag as false, and hence I get a dissimilarity function. So I could quickly toggle this, and I could get the similarity function. So I know that these values, when they switch, irrespective of what those categorical variables are, they are switching in tune with each other. So if one value increases, that means if x increases, then y increases, and if x decreases, then y decreases.